Hey guys, Mr. Catlin here with your homework help. Starting with lesson 6. The diameter of a bike wheel is 27 inches. So I'm going to get my writing tool here. Let's go red. We've got a bike wheel and it has a diameter of 27 inches. It's an adult size bike. Most of them are larger. And if the wheel makes 15 complete rotations, how far does the bike travel? Okay, so first of all, we need to determine, is this an area problem or a circumference problem? It is in lesson 6, so it's clearly about circumference. So we know that we can find circumference by taking the diameter and multiplying it by pi, or 3.14. So here all we have to do is 27 times pi, and we'll find out how far it is around this thing. So let me go to my calculator for Desmos. So 27 times pi is 85.59. So 85.59 is the length of the circumference of the tire. That's if it was to unravel itself one time, it would go 85.59 inches. And this question says, well, what if it made 15 complete rotations? So we would have to multiply 85.59 times 15 to find out what that would be. So let's knock that out real quick over here. Let's take our answer and multiply by 15. And we get 1,283.85. 1,283.85. And that would be inches. There's our answer for the first problem. All right, let's move on to the next one. The wheels on Kieran's bike are 64 inches in circumference. So that means when you unravel his circle, it is 64 inches. How many times does the wheel rotate if he rides 300 yards? Okay, so this one's kind of intense. We've got to find, we don't have to find circumference or a diameter here. We're using circumference to find out how far it goes. We want this thing to continue to go for a total of 300 yards. Well, we're in inches and we need to convert to yards. So let's do that first. Let's change. We'll do that over here. Inches to yards. Well, we know that in 1 yard, there are 3 feet. And 3 feet, 3 times 12 would be 36 inches. So we know that we have this constant of 36 to get us from yards to inches. So if we're going 300 yards, we got to do 300 times 36 to find out how many inches that is. So 300 times 36, that's 10,800 inches. Yikes. So 10,800, man, that's a lot of inches. 800 inches. And every rotation, it's going to go 64 because that's the length of the circumference. So if I want to go this far, 10,800 inches, and every time it spins, it goes 64 of those, then this is a straight up division problem. We need to do 10,800 divided by 64, and that will tell us what our answer here is. So I already got 10,800 in my calculator. So I'm just going to divide that by 64. So I'm going to take that answer, divide it by 64, and we should have our solution, 168.75. So 168.75 rotations. It says how many times does the wheel rotate if you ride 300 yards? That would be our number of rotations, 168.75. All right, let's move on to the next one. Find the area of the polygon. Okay, a couple of different ways to do this. You could split this up into 3 rectangles, or you could find the area of the whole thing and take away the rectangles that you know. So, gosh, what would be easiest here? I think I'm going to go with the subtraction route. That's just the way that we've done them in class. So I'm going to find the area of this big rectangle here, and then I'm going to take away this, and take away this. All right, so big area. My strategy, rectangle minus, not equal, minus the red one that I drew. So minus the red rectangle. All right, actually it looks like a square. and then minus the blue rectangle that's kind of long and skinny, right? And then minus the green one that's kind of more chunky, right? So the big rectangle, which is probably, I could show more like this, minus those things, should equal, all of that should equal the area of our shape, area of polygon. All right. So big one. It looks like it is 3, 3. So that puts us 9 centimeters across here. And the height of it appears to be what, a 2 and a 1. And let's see, this is 4. So that makes this 2 also. 2, 2, and 1. That would be 5. So 5 centimeters. So altogether is 45 centimeters. Now we start taking away. This appears to be 1 by 1 because of that length, right? So 1 times 1 is a 1 centimeter squared area. And then the blue one is 1 by 3. You can see that from across the way. So a 1 by 3 would be 3 square centimeters. And then the green one seems to be the largest. It is 3 by 2. So that is 6 square centimeters. So for me to find the area of everything that's involved here, I'm going to, oh, I made a mistake. I just realized I made a mistake. And some of you watching the video are like, Mr. Catlin, that's not 9. That's supposed to be 6. I don't know why I multiplied those. So let's go back and fix that. Sorry. This should be 6. I was like, man, this seems like a lot of space for such a small figure. This should be 6, which would make this into 36. I'm sorry, 30. Because 6 times 5 is 30. Sorry about that, guys. Okay, so we got to do 30 minus 1 minus 3 minus 6, and that will give us our answer. So 6, 3, and 1 make 10. So 20 minus 10, when you combine all those together, gives us, sorry, I wrote that wrong down too. Man, I am off my game today. 30 minus the 10 from all of these collectively, right, gives us an answer of 20 centimeters squared. That one probably could have been easier doing it as that rectangle, and that rectangle. But I digress. Let's move on to the last problem. Let's finish this first page, which seems to have taken forever. The radius of the Earth is approximately 6,400 kilometers. So here's the Earth. Here's its radius. It's 6,400 kilometers. The equator is the circle around the Earth, dividing it into northern and southern hemispheres. Yes, that is the equator. The center of the Earth is also the center of the equator. What is the length of the equator? Okay, so if this is our radius of our Earth, center of the Earth coming out to here, this is essentially asking you, so of course the Earth is a sphere, but if we wrapped a belt around the Earth, the equator would be like its belt. So it would be like a circle. And what they've given us here is the radius of the Earth, which is from center of the Earth to the surface. And so really they're just asking us to find the circumference here. So all we have to do is, how do we take radius, find diameter, and then get to circumference? Well, we have a couple of constants of proportionality that help us out with that. First of all, we double to get to the diameter. So if the Earth has a radius of 6,400, then we double 64, and that would give us 128. We add our zeros there. So that would be 12,800 to be our diameter. That would be the distance all the way across. And to find the equator length, that would be the circumference, which we have a constant of pi, or 3.14, to find. So our job is 12,800 times pi. So let's do that real quick. 12,800 times pi, 3.14. And voila, 40,192 is our approximation. So 92 kilometers. That is our approximation for the length of the Earth's equator. And that finishes up lesson 6.